All right, welcome back. From this video, we're moving on to using Python. So hopefully you have a better understanding of using Excel, and if you have been using Excel before, hopefully you learned something new. So today, what we'll do in this video is go over why we are using specifically Python, and also cover some of the basics. So if you haven't done any of the Python, this video should be helpful to you. All right, let's get to it. So why Python? Well, Python is free, elegant, powerful, and well, quite relevant nowadays because a lot of software engineering places will use Python alongside with Java, C, and whatnot. So Python is one of the most popular language that gets used nowadays because it has a lot of flexibility. It can be used in multiple platforms, and it's very easy to use with quite a comprehensive functionalities, right? And in addition to that, one of the key factors is that Python is very easy to learn. Well, it comes with the simple syntax as well as reading the code makes it easy to understand what it's supposed to do, and that's what we're trying to emphasize as well. In addition to that, we have a lot of libraries that enables you to do a lot of things. So we'll cover some of the external libraries in this unit, such as Numpy, SciPy, and etc. But once you get hang of using Python, then you can start looking at using some of the cool libraries for doing things like machine learning or deep learning, etc. and so forth, right? So Python provides you almost a full package for you to do pretty much everything you need to do in software engineering, right? So in order to use Python, we're going to be using this specific IDE, Wing101. So this is what it looks like, right? So in the requirement, I have specified, I think, to use version 3.7 or higher. Yeah, so try to use 3.7 and higher. In the labs, we have 3.8. I'm currently using 3.6, but it shouldn't make too much of a difference for our purposes, right? But don't go below 3.5. That's when a little bit of some basics start to function slightly differently, right? Of course, there are different IDEs that you can use. Wing is just one of the IDEs for Python. You're welcome to use other IDEs that you're familiar with, but if you don't know anything about IDEs, this is where we will start with, right? So Wing IDE looks like this. When you create a new project, it will automatically create an untitled blank page. This is where you will start coding. Okay. You'll get to learn how to do this very shortly. And one of the key things is it will automatically highlight the syntax for you. And it has a lot of cool features, like if you highlight some words, it will also highlight some of the other words that are the same in different locations and so forth. And this is the shell. Okay, we'll come to the shell right now. So if you are ever in doubt, you can use the help function. There's a lot of Wing manuals, tutorials, and so forth you can use. If you have a large set of codes, then you can always search it. You can always create new pages to do some other modules and etc. Save, open, debug, and we will cover all those functionalities as we go along. Okay, so let's cover the basics. What does Python do? Essentially, Python has an engine and you interact through the shell. So the Python engine is the one that executes the Python instructions, and pretty much when we say Python executes something, it means it's going to interpret what you have written as a code, and when those instructions are run, those are your programs, then it's going to calculate or whatever you instructed it to do, and then return the result back to you. Okay, and shell is the medium that you interact with the Python engine. Okay, so as we mentioned before, and as also highlighted here, this is the where did it go? This is the Python shell. Okay, and here you can write snippets of Python code, and it will do stuff. For example, print hello. It's going to print me something like this, or put some calculations, 6 plus 1, and it's going to evaluate, pass in the string letter. You'll cover this soon. It's just going to return this. So whatever the instructions you give here, it's going to do it, as long as it understands what you're trying to do. So that's the basic underlying of how Python works. You give it a set of instructions, which is your code. It passes on to the Python engine. Python engine evaluates your code, and whatever you instructed it to do, it will return it back to you through the shell. That's the normal way of interacting with it. Okay. So Python shell, what it does is it's going to read the input continuously. And then it's going to calculate whatever you set it out to do, and then return back to you the result. Okay, that's the role of the shell. Shell takes your code, do something at the back with the engine, and give it back to you. Okay, so Python allows you to perform calculations on numbers and other values at its interactive prompt. So we just tested this before. We add calculations. It's going to directly interpret the answer and return it back to you. Okay. So this way you can quickly check things or confirm that your code is working or not as well. Okay. So that's the basics of the Python engine and the Python shell. So now we're going to cover some more details about how Python works. So first thing is understanding about executing statements. So when you write code, each line or each set of instructions, we call it a statement, and you can execute single statement in Python through the shell. Okay, so before we wrote 2 plus 3, which evaluated to 5. That's a statement that we executed as a single statement, right? And of course, we can do some other things like 22 divided by 7, 3 times 2, or print something. So these are all part of a single statement. They're not working together to do anything, but it's just directly interpreting the statement and returning it back to us. Okay. So to make this more powerful, this is where things slowly build together. So expressions is something that can be evaluated to yield a value, so basically saving it, and reuse it for something else, right? So next item is expressions, and expression is something that can be evaluated to yield a value. So what we saw here before, the whole thing is a statement, but if a statement is doing something that requires calculations like 2 plus 3 or etc., then we can call this as an expression, right? So typically a sequence of operands and operators will form an expression. Okay, so here 17 plus 3 divided by 4, 17 plus 3 divided by 4, okay, and as a result it's giving me a number which is 5. Okay, and operands are the numbers. Oh, I have a typo, this should be 17. Operators are pluses and division, and finally it evaluates to 5.0. Okay, so a key note here is that you should remember that there is a 0.5 here. Why do you think that is? If you guessed that division is a float operator, that's correct. Okay, so for us, we know that it's 5, but for Python, when you do a division, you don't know how many decimal points you're going to get, so it will convert the type of the evaluated expression into a float type. So, and by default, float type, even if it's a whole number, it will add the 0.0 at the end to indicate that this number is type float. Okay. So in addition to this, arithmetic operators, we have plus, minus, multiplications, division. In addition to this, we have what we call an integer division. So this will drop all of the remaining values after the point. So if we do, instead of single division, but use a 2 division 1, what do you think we're going to get? That's right. So we have removed 0.5 at the end. But remember that this is not a round function, so it's not going to round up the value or round down anything. It's just going to remove anything after the point. Okay. A difference to Excel, in Python, if you want to do an exponent, exponentiation, we have to use a double star sign. Okay. So let's try 2 to the power of 3. This was an expression that you could use in Excel, but actually this head operator in Python means something else. It's a binary operator, which we will not be covering in this unit. So you can dig into it, but it's not assessed here. So instead, you need to do 2 to the power of 3, which in this instance, we get the correct result of value 8. Okay, and last one is modulus, which can be done with the percentage sign. So a modulus is calculating what is the remainder after dividing the value. So if I have 10 modulus 3, what do you think we're going to get? 1. Why? Because 3, you can divide 10 3 times, which is 9, and the remaining value is 1. So remember, modulus is the remaining value after you divide the whole number as much as possible. Okay, so we just tested the 2 to the power of 3 and also the division compared to double division. So here it shows you get 8.6666 recurring compared to just 8. You can test this yourself in the Python shell now. Okay, and also the modulus. You can pause the video whenever you need it. Okay, and also same as mathematical rules, the same one follows. If you heard about the bit math, same idea, right? So we have the exponent that is highest. Of course, we'll have brackets before this. So if we have brackets, that gets executed first. But out of the operators, the exponent, and then we have multiplication, division, integer division, and modulus, all grouped together, and then the plus minus. We have some other operators, but we'll cover them as we go along. Okay. If they have the same precedence, then you will execute them left to right. Okay. So here, you use the parentheses, the brackets, to separate or give higher precedence to some operators that has lower than the others. Okay. So now we need to understand a bit about values and types. Values, or we term it here objects. We don't really cover object-oriented programming here, but we'll cover a bit of that later on. So you can just call it values for now. Essentially, all the things we create in Python will be an object, including values. Okay, so object is the highest hierarchy, but yeah, don't worry too much about that. It will make sense as we go along. So for example, we have 0 or 5.1 or -99. These are all values. Okay. Some other types of values can be things like high or inside a square bracket, which is called a list. High is a string. Inside a square bracket is a list of strings. It contains strings. If it was numbers, it will be list of numbers, and so forth. Those are all types of values that we can have in Python. Okay, so we will see these very shortly in a few videos later. Okay, so types are classification of values, and each type allows certain operations. So we have seen two number types so far. One is an integer, which is a whole number. For example, 1, 2, 3, 4. It can be any size. It will store it as much as possible. And the other one is floats. Okay, so floats are the numbers with fractional bits, right? The one with the point something. Okay, so in other types, it has other names. For example, in C, we have both floats and doubles, but that's more about the size of the variable storage. So don't worry too much about that. In Python, we just call it floats. And whenever somebody says floats, it's not somebody floating on the water, but rather it's the numbers with point something. Yeah, even if it has 1.0, that's still counted as a float type. Okay, so the value may be a whole number, but if it has 0 associated with it, then that value is of type floats. Okay. It has roughly 16 digits accuracy. So as you know, computers working with zeros and ones, so storing values of exact value is almost always impossible unless it's 2 to the power of something, right? So for example, 1.1 is actually an approximate inside a computer system. It's something like 1.10000000000 some other values, right? Whereas values like 1.5, 1.25, 1.125, something that falls into the categories of 2 to the power of something, will have an exact representation, right? Okay, so where did it go? Here, 1.1 minus 1.09. Okay, so when we type this 1.1 minus 1.09, we expect it to be a 0.01, right? But because 1.1 cannot be stored as an exact value, we see something like 0.01 and a bunch of zeros and a 9. Okay, so whenever you're dealing with floats, you have to be careful not to trust its precision as you should. So never do float number comparisons. Okay, this will make more sense when we deal with the conditions later. Okay. Other things include complex numbers. So Python can handle complex numbers as well. Strings, lists, which are here. This is a string and this is a list. We'll see in, it says week 4, but in terms of videos, we just skip through the strings and lists lectures. And then also Boolean, which we'll cover in the conditions. Right, so now we know how to create expressions, execute statements in Python through the Python shell. Okay, and we also learned about a bit of a types. So although it's numbers and it's not necessarily be the same type, it may be an integer, it may be a float, maybe something else like complex numbers, etc. Right? What we do is that when we calculate those expressions, maybe you want to use them later on, right? So in that aspect, what we want to do is create what we call a variable. A variable is something like a storage container. It's going to hold the value of your expression for you, and later when you need to use that value again, you just access the storage container with the variable and use it again. Okay. So can I increase the size of the, not sure. So let's have a look at the example. Says my age, I'm just going to type age equals 100 divided by 2 minus 1. So what do you think it's going to calculate? If you answered 100, yeah. But if you answered 49, absolutely correct, right? But in this instance, it doesn't show me like before. So if I just typed expressions without an equal sign, then it's going to return me the answer straight away to the shell. But if I store it onto a variable, then it's not going to show me. Rather, I have to access the container, the variable. So if I type age, it shows me the value that's stored inside this variable. Okay. There's a few rules about variables. It has to have a letter to start with. It can also start with an underscore, but other than that, it's going to give you an error. So make sure it starts with a letter. Then it can be mixed with like numbers as well. So variable name starts with letter or underscore, and then it can be any mixture of alphanumeric values and underscores. Okay, so here my age is a valid variable name, although I haven't defined it. Equals 1. Okay, that's a valid name. My age equals 1 is also a valid variable name, but age equals 1 is not a valid variable name because you cannot start a variable name with numbers, but I can start with an underscore, which is a valid variable name. Okay. So in that sense, you could really create some really gibberish variable names, which people do quite often, right? But we also try to cover some styles, so this will be covered in a couple of videos later. So what's happening with this? Well, works out the values of the right-hand side, the expression, and whatever the value that gets returned gets saved onto the left-hand side. Okay, so this is important. You evaluate the right-hand side, or is it this side for you? Right-hand side, and then it gets stored onto the left-hand side. And Python allows multiple expression interpretations. So if the left-hand side, if the right-hand side returns multiple values, I can map it to multiple variables onto the right-hand side. But don't worry about this for now. I'll cover this when we cover the lists later. Okay, so in this example, my age equals 99. My age equals 99. When I type this, what's actually happening is in the computer we have the memory space, right? And it's called the heap, right? In the computer, the heap stores all those values that we want to keep and reuse it. So here, the heap or the object store will keep a dictionary of variable names, right? So here's a bunch of dictionary names, variable names. So later when you want to use it, it accesses this dictionary to find the value that you have stored it last time, so it knows what value is inside. So when I typed my age equals 99, essentially this my age has been created into the dictionary, and a new integer object called 99 gets created in a space, and now we get a reference. This arrow is a reference. So my age variable is referencing value 99. Okay, so later when I use it, basically I'm getting this reference back to me, which is pointing at 99. Okay. So there's more demo on this website, so please do follow and have a look if you are a little bit unsure about this. Okay. And in the heap, we can have some other objects floating around. So for instance, I just typed numbers 37.5. Okay. I just created a value 37.5 inside the heap. However, I didn't have any variables pointing to this number, so essentially I don't have any dictionary entry pointing to this new value that I just created inside the heap. Therefore, if I'm starting to run out of space, this value may be overridden, right? So if I have references, normally they will have the boundary checks, so they're not going to be overridden, but stuff like this that are just created in the heap without any references can be wiped out. Okay. So what is a reference? Well, computer has lots of random access memory called RAM. So hopefully you know about RAMs. I will not explain this. And bytes are just numbers, right? So it's from 0 all the way up to whatever the 4 GB number will be, right? And each number is called the address. And what a reference to an object is the address in the memory at which the object is stored. So essentially the variable stores the number, which is the address, and that address is pointing to objects. Okay? So in Python, it's called object identity. Okay? So essentially that arrow that you saw before, this one is just an address, and when you go to the address, the value is stored in that box of memory. Okay? So a dictionary entry consists of variable name called a string together with the identity or object it references. So essentially this dictionary here has two parts. One is the string part, which is the name, my age. The other part is the address, which is this reference. Okay. Yeah. So how do we use variables? Using variables is actually quite easy. You just use the variable name in the equation where you want to use the value on the right hand side. So here, so here I have my age already, and then we're going to calculate his age equals my age minus 1. Okay, so what I just did is created a new dictionary entry, his age, and well, my age was 99, so in this instance it's going to be 98. Okay, so check it, his age, it is indeed 98, but we have another expression that we want to execute, which is my age equals my age plus 1. My age equals my age plus 1. So what does this do? We have the same variable name on both sides of the equation. Well, remember the rule is that you evaluate the right hand side first and then save it onto the left hand side. So my age is currently 99, and you express, you put the value in here, 99 plus 1, so you calculate 100. So we have evaluated the right hand side and saved that onto the left hand side, which is my age. So I am overriding my value by increasing the value by 1. So previously my age was pointing at 99, but after executing the second expression, it's going to point to 100. So after I do this and check my age, it is now value 100. So the integer value 99 was in the heap somewhere, but now it no longer has a reference to it. Okay. One keynote here is that Python is case sensitive, so if you do give some different cases to the names, it will not understand what you're trying to find. Okay, so my age here with a capital M is different to my age here with a small letter m. Okay. Moreover, we can combine operators. So we often use operations like count equals count plus 1, or size equals 2 times the size. Essentially, count equals count plus 1 is incrementing by 1, and size equals 2 times the size is doubling the current value of the size. And Python allows you to combine these. For example, count equals 1. So if I type count, I have 1. Count equals count plus 1. Then now it becomes 2. If I run this again, count is 3. If you want to access the previous expressions you typed in the Python shell, you can just simply press the up arrow, then you can access them. Okay. You can write this in a short form, count plus equals 1, because you are reusing the variable on both sides. So it's essentially I'm adding on the one value. So this is a valid syntax in Python, which is essentially doing the same thing, increasing it by 1. Okay. Same with the size. Size equals 1. size equals times equals 2. Size times equals 2, and we access size is now 2. Do it again, it has doubled, and so forth, right? So in that sense, we can combine operators for simple operations like this, like incrementing or regularly doubling the size, or whatever the factor is. And you may have figured out when I was playing with writing code in the pages, some names gets highlighted. So for example, here def gets highlighted as a thick blue color, print gets highlighted as a light, what color is that? Light bluish, greenish color, right? And there are some other reserved letters. If is a thick green. Else is also class, for, and, or, in, assert. So whenever you type something and it gives you a thick blue color in the Wing IDE, it means they are reserved variable names. So these are the reserved names which you cannot use as a variable names. They are reserved for Python to use. So for example, I want to create a variable name called if equals 3. It's going to complain because this is a reserved name. You cannot use this as a variable name. Okay. The key difference with the thick blue color compared to light blue-greenish color is this is the function that you have, whereas this is the built-in reserved name that you cannot use as a variable name. Here, print you can, but essentially you will override the function to do something else. Okay. So we talked about types of variables, and essentially sometimes we don't know what type of variable we are dealing with, and we need to understand this because what we can do with the type differs based on what type they are. Okay. So for example, I have my age, it says 100, but to make sure that this is an integer, I can check the type by calling the type function, my age. Okay. And it tells me that this is a class integer, so I can confirm that this is an integer type. Okay. We can also check some other types, for example 4.5 plus 0j, okay, and it says it's class complex, so whenever you see a number formatted in such format with a float plus some number and a j, then this is going to give you a complex numbers. Okay, so you can type in other things like type hello. What is the type of hello? It's string. Type of 6.5, this is going to be float. Type of 6.0 is also float because it has a point and a value, and so forth, right? And also the function locals will tell you what local variables are currently defined. So that means locals, yeah, make it a bit bigger, it's easy to see. So here we have some predefined names. You don't have to worry about that, but here near the end, after all the predefined ones, I have a variable called age, my one age, underscore age, and so forth. So all the variable types I have created up here is in the dictionary, and this shows us what's inside the dictionary. So use the locals if you forgot about the names of your variables. This can be quite useful. Okay. And further, we can convert the type of variables from one to the other if it's compatible. Okay, so obviously you cannot convert the type of the string to numbers and so forth if it doesn't make sense, but if it makes sense to change the type, then Python will allow you to do that quite easily. So for example, we have 3.4 is float, but we can create it as an integer. If you do this, it's just going to lose all the point values. So whatever you had behind is going to be lost. So if I have int of 3.9, it's going to be 3. That's right, you just lose the values. Okay. Same with float. I can create float numbers by passing in some values, and then it's just going to change the type to float. Same with the complex numbers, so you can test with that. In some cases, Python will automatically perform conversions for you. So if you try to add integers and floats, because the type float stores more values, for example, the point whatever, but integers don't, it will change the type, will be converted to float. So here's an example: 3 plus 3.4 is going to be 6.4. So we can easily check type. 3 plus 3.4. What this is going to do is evaluate the expression first inside the bracket and then call the type function to check what it is. And then obviously here we get a float because the evaluated value is 6.4. Okay. So we are here at the end. We are moving on to functions in the next video. I'll see you there.